Hello, at Thermitis Biotech, we can use our plasmonic material and coat micron-sized beads for use in flow cytometry assays and cell FACS. These beads, which can range from size from 2 micron up to 8 micron, can either be standard plasmonic beads that enhance fluorescence up to 100-fold, or they can also incorporate a magnetic core so that they can do magnetic capture of biomarkers followed by flow cytometry assays, still with the 100-fold fluorescence amplification. On the top right, you see a basic schematic of what the beads look like, where they will capture a biomarker of choice on the surface, and then as they pass through flow cytometry, they'll emit a high degree of front scattering as well as amplified fluorescence. On the bottom right, we can see a comparison between standard glass beads and our plasmonic gold beads, where in the Psi5 channel, fluorescence is amplified 100-fold. And this is seen for several different fluorophores in the red and near infrared on flow cytometry. We've performed this assay to detect various types of cytokines. When looking at a typical cytokine, this is most likely human IL-6. We see that using standard glass beads, the IL-6 limit of detection is around 10 picomolar. With our plasmonic gold beads, we're able to achieve roughly 10 femtomolar detection limit, over a 3-fold improvement. We also have a larger dynamic range of 7-fold dynamic range. And this capture is done by using a capture antibody that's specific for IL-6 and then a detection antibody labeled with Psi5 dye. Now, one question the researcher might have is maybe that gold beads are just better at capturing IL-6. It's not the fluorescence enhancement from the plasmonic surface, but it's just that the plasmonic surface for some reason allows extra capture of IL-6, and that is not actually the case. A test was done with standard colorimetric assay looking at an absorbance change where the plasmonic gold surface does not affect absorbance. And it's seen that there is no difference between a glass bead and a plasmonic gold bead. So this improved limit of detection is solely due to the amplified fluorescence of the plasmonic gold beads. Now, this can be used for multiplex detection as well. In a recent publication, people were able to multiplex 6 different types of biomarkers, most of them cytokines, by varying 2 types of bead sizes, 4 micron and 8 micron plasmonic gold bead sizes. So you're able to differentiate based on the side scattering and front scattering profiles in flow cytometry. And by using 3 different dyes, or actually 2 different dyes and then one labeled with no dye, you're able to differentiate 3 different biomarkers at each size range. So with 2 size ranges and 3 biomarkers, we get 6 total biomarkers that could be determined with one test. This is how you can use these plasmonic gold beads for multiplex detection of various biomarkers where you might not be able to diagnose a disease state with just one biomarker, but several biomarkers together can give you a better idea of the overall picture. Like with cytokines, certain types of cardiovascular disease, oncology, and cancer detection, usually you're looking for multiple biomarkers. And this is where the plasmonic gold beads are most versatile.